All right. Hello, everyone here. Uh, let's start our workshop today. So this workshop will be a rather short one, and it's going to introduce the topic of multiplayer in Godot. And today we're just gonna focus on the connection logic, meaning that we create a server and allow other players to connect to the server. And we do some simple RPC, meaning remote procedure calls, that allows one player to do something to other players within the same connection. All right. So the first concept will be peers. So multiplayer in Godot works as peer connection. So there's some high-level API in Godot that allows us to create these peer connections, and there are some abstracted functions that is quite convenient for us to set up this connection. Right. So for this one, we will be using this eNet multiplayer peer instance. This eNet is some internet protocol that is related to reliable UDP. Right? It's not TCP, but it's UDP, but reliable. Okay. So we will be using this instance to create our client and server peers. All right, let's go to Godot. Okay, so for this game project, it's the same one that we have been using, only that I added this lobby scene. This lobby will be where the players host the game and join the game. And after the game starts, we will enter the same boss fighting game, right? Okay, so let's see. In this lobby scene, we have a few simple elements. The first one is a line edit that allows players to input their names. There's a host button, there's a join button, and there's a start button that I've hidden it for now, right? It's only going to be visible after the player hosts the game. And there's a label for logging of any connection messages that we're going to use later. And there's also a timer for us to debug, to display all the names of all players in this room. All right, let's look at the script. Okay, so it's a rather simple script. We just have a few variables and some signal functions connected with all those buttons as well as the timer. Right. So the first thing we're going to implement is within the host game button pressed and join game button pressed. Right. So when these buttons are pressed, what we want to do is to create a peer that is related to the server or the client or the other player peer, right? Okay, so for this on host game button pressed, let's just add the server peer. So let's create a variable server underscore peer. Maybe I should enlarge a bit. Server peer equals, we'll be using the class name that we mentioned just now, eNet multiplayer peer. Yeah. Is it new? Dot new. Right. eNet multiplayer peer dot new. Right. So this will just create a peer connection for us. And then we can call some functions on this peer connection. Dot connect server. Is it server? Create server. Right. So this function is going to create a server on this particular peer connection. And it takes in a few arguments. Let's see, there's a port argument, max clients, right? Max channels. Okay, so we're gonna define some of these constants in our game. So this create server will create a server instance on this peer connection at the IP address of the server connection, right? There's no need to define the IP address here, but it's better that we keep the IP address as a constant to be used in the connections later. Okay, so let's just define the default connection information. Let's say constant IP address. We'll be just testing this locally, so we will put a string of 127.0.0.1, which stands for the localhost IP address. Right. And the constant port will be a number. And this number, let's just do 7777 because 7 is a good number. Okay, and wait, I should capitalize this port. And a constant max clients. This just literally is the max number of players of peer connections that is allowed in this room, right? Let's do maybe 10. Okay, so back to our create server function, we're just gonna add these new constants. And the first one will be the port, and then the max client being the max client. Okay, let's just do this first and see what happens. Actually, let's do the same for the client first and see what happens. So for the client, we do the same thing. Define a client peer to be enet multiplayer peer.new, right? And then client peer. For this one, we don't create server, we create client. You see here, it requires an IP address and a port, right? So let's just do the IP address we defined earlier as well as the port. Okay, right. Actually, we are not ready to test it yet, but let's just print this. All right. Let's call this var connection equals this, and let's just print the connection. Let's see what is being printed. Print connection. Okay, so how do we test this on our local computer? Other than if you ask a friend to connect to your hotspot and just doing your local network, there's an easier way to do just on your computer. So let's go to the debug tab, and there's one tab called customize run instances. Okay, so I've set this to 2. Maybe I think it's 1 on your computers right now. So just change this to 2. And this defines the number of instances that we run concurrently when we press this play button. Let's do it. Okay, you see that there are 2 instances being run on the same at the same time, right? Let's just try host game on one of them, and it says 0. So what does 0 mean? 0 means there's no error, right? Same as your, I don't know, some of your programming language, the return value of certain functions or system calls. 0 stands for no issue, no error, right? We can also join game, right? So behind the scene, there is already a connection being established. The instance on the left has created a server on port 7777 of your local machine, and the right one has a peer instance that has joined this connection. Okay, so right, let's close these instances. And another thing worth mentioning is when you create the client and server, there will be an ID being automatically assigned to this connection, to this, actually it's to the multiplayer instance that is, I think it's a singleton in the instance, in the game instance that you run, right? It assigns this ID to that multiplayer instance. And we can actually print this ID. Let's go to on host game button pressed. I think it's just called multiplayer. Yeah. So you can access this property, of your node. Every node has a property called multiplayer. It stands for the singleton multiplayer instance that this particular node is being assigned, it has access to, right? We can print the multiplayer dot get ID, get unique ID. And we can also print multiplayer dot get unique ID. Okay, let's try this out. So when you host the game, you can see that this unique ID being printed is 1. And when you join the game, wait. Huh? It's not supposed to be 1. Where? Let me try just joining. There's some issue here. But anyways, let's just pretend we never see that. Okay, so the peer ID, the ID of a peer or the ID of a client is actually a random integer that is not equal to 1. I'm not sure why it's 1. Maybe because, I don't know. I don't know why, but it's supposed to be not 1. We'll see this later. So, I mean, the server will always have the default ID of 1, but the peer ID is a random integer that is different to any previous IDs assigned. Okay, right. Maybe we can debug this later. We can see the different IDs later after we add all the multiplayer signals, right? So Godot has also has a few signals that is built in with the multiplayer instance, right? So for this multiplayer instance, we can connect this to a few signals, and these signals are called when this multiplayer has some events, right? And we can do these signals, we can connect these signals in the ready function. I mean, the support is not there yet because you would expect the multiplayer signals to be in this, in the inspector, but no, there isn't. Godot hasn't done that yet. So you will have to manually connect the signals in the ready function. Right, I'll show you how to do it. So we can do multiplayer dot connect, right? So this connect, it just connects the signal defined by a function name to this multiplayer. I know, I think it shouldn't be connected to this multiplayer, but should be connecting to a function, right? It's called this multiplayer dot connected to server dot connect something, connect a callable to this signal function inside multiplayer, right? We just call it, we just use the same name, connect to server. Wait, let me check, should it be a string or? Oh, it should be a callable, right? So we have to define this function first and pass the name of this function to this connect function, right? Let's just write a connect to server, right? And we will define this connected to server function later. And this just means that when there is a new multiplayer instance being connected to the server, this function we define will be called, right? So we can define it underneath function. Actually, I think it's a good programming practice to, I mean, differentiate this and this. So let's just add an underscore before. So underscore connected to server. Right. There should be an ID argument here. Yeah, signaling the ID of the multiplayer instance being connected to the server. So let's just log message. We can just do this player, this percentage sign ID is connected to server. Okay, and then percentage ID, right? Passing this variable to this string. Okay, so now we are done, right? So we can test this. When a player is connected, it should log this message. Right. So we host the game here and join game. And it's not. Let's see why. Connected to server. Oh yeah. That's interesting. Oh, this one actually doesn't have. Okay, I should have referred to the signal functions, right? Okay, so okay. I think it's a good idea that we look at these signals first, right? There shouldn't be any argument here. That's why it wasn't called successfully just now. Okay, so okay, let's just go through these signals first. The function that I had in mind should be this one, peer connected, right? So this means a peer, a new peer, a new client has been connected to this server, and this one has an ID. And the same for peer disconnected, when one of the player has disconnected from the server, right? The function we had just now, connected to server, means that the current multiplayer instance is connected to server, right? Your current client, when you as a player connect to this server, then only for you this function will be called, right? And similarly the connection failed, and also server disconnected means that the server instance has disconnected, and this signal will be called to any will be emitted to every connection that has been established, right? Okay, let's go back and correct this. Okay. So this one should have no argument, and the message should be, instead of some player being connected, it should be you have been successfully connected to server, right? Okay, we should finish these functions first before we connect the signals. That's more logical. Let's do function underscore connection fail. Is it? Connection failed. Right. Let's just copy this line over. Log message. You have failed to connect to server. Right? And the next one will be server disconnected. So function underscore server disconnected. Right, let's log this. Log message. Server is disconnected. Please join another room. Right. And now it's a peer connected or peer disconnected. So underscore peer connected, and this time we have an ID to use. So we can log message, log message player percentage ID has entered the room. Right. Now percentage ID. Okay. Now for disconnected, let's just copy paste this entire function. So peer disconnected. Log message, player ID has left the room. Okay. All right. I hope the meaning behind each of this function is clear to you from the name, right? I made a mistake just now, and yeah, I hope it's clear now. Okay, so let's just connect all these functions to our signals. We already have connected to server. Let's do multiplayer dot connection failed. Let's connect that with our underscore connection failed. It should be a callable, so don't include the bracket. Now multiplayer dot server disconnected dot connect server disconnected. Okay. Now multiplayer dot peer connected dot connect underscore peer connected. And last but not least, peer disconnected. Okay, now we can try out. Okay, let's host game here and join game. And it's still not working. I miss out a line somewhere. Wait, that one line makes a difference. You tell me which line? Uh, oh, this line. Yeah, right, this line. Oh my God. That's why we had the issue with the ID just now. So we have to, in order for the multiplayer API to work, for this multiplayer API to work, we have to tell Godot which peer that it should represent, right? We must do this by adding multiplayer dot peer, multiplayer peer. Yeah, this is a property of this multiplayer, and we must pass this server peer to it, right? And we should do the same for this multiplayer dot multiplayer peer equals blind peer, right? Let's do this in front of the printing of the ID to verify that it works. Okay, let's see. Host game one. Eh? Oh, sorry, not percentage ID, percentage D. Sorry. This is a percentage. This is a format for the integer, right? Not percentage ID. Always confused with Python tree syntax. Yeah. Host game. Join game. Okay. Now it works. Okay, now everything works. Okay, just because of one line. So you can see that when you print the unique ID, right? We have one here, which is for the host, and this number, this random number for the client. All right. And in the lobby, there are strings being printed because of our logging. So you can see that, okay, let's when the player press join game, right? There is a you have been successfully connected to server due to this connected to server signal, right? And there's also other signals for the peer connected, right? So for the host, is able to see that this player ID has entered the room, and it's the same for the player. All right. Okay, let's close this. Okay, so that's for the signals. That's basically it, right? I mean, it's the signal is just a one-time thing when there's a connection or disconnection event. You can do other things under these signals, which we're gonna cover now. Okay. Right. So RPC stands for remote procedure calls. Right. So what are remote procedure calls? It's procedural call is just a function you define that you can call remotely, right? So think of it as an API on each peer, an API on each device that other devices can call, right? You have defined this function on this peer that can be accessed by others, right? That sounds quite cool, right? Also quite dangerous. I mean, you have to use this for multiplayer games. And in Godot, there's an annotation at RPC, right? You use this annotation to declare this function is a remote procedure call. Right. So let's just demonstrate the RPC first. So let's have a function, right? Let's have a function to start the game. And you would want the host to be able to start game for everyone, right? But how would you do that? You have to use RPC to call this function on other players, right? Okay, so let's just have a function start game, right? So we have this level 1 instance already, right? Let's just var level 1. Level 1 equals this level 1 scene dot instantiate. Right, let's just simply get parent dot add child, this level 1. Right, this will start the game. And also maybe you want to remove this lobby scene. So self.queue_free. Okay. So now this is nothing special. This is just a simple function. And we can make it an RPC by having this annotation RPC. Right. You have to add a bracket here because there is some arguments that this annotation takes in. Okay, let's see the arguments. You see there's any peer authority. So this means this option means that whether this RPC can be called by anyone or just the host, or just those with privilege and those with admin privilege, right? And there's also a call local or call remote, means that whether when you call this RPC, it is only taking effect remotely on other peers, or the effect includes yourself, includes the host itself. That is called local. Right. And this reliable, unreliable ordered is just related to the network protocol, the UDP TCP we were talking about. Right. Remember that all of them are UDP, but yeah, it's just whether it ensures this is being called or not. Of course, I also have we also have a trade-off for the performance, for the time that this finishes, right? So for this one, we want this to be authority only, right? Authority and call local because the server also plays a game, right? And also we want to make sure it's reliable, right? It starts a game for everyone. All right, so we have defined this RPC call, and we can do the RPC in this signal for the start game button. And the way you call RPC is just it's not just calling the function itself, right? You have to do start game dot RPC, right? Note that there are two functions here. One is the RPC, one is RPC ID. So RPC means you call it for every peer in this connection. And RPC ID is you only target the ID, the multiplayer ID of that particular connection, that particular peer instance that you want to call, right? For this one, let's just do RPC bracket. Then when the start game button is being pressed, it's going to call the RPC, right? Call RPC on every peer. And it's going to refer to this RPC configuration in your decorator. It's going to verify that it's from an authority, so it's able to call. It's going to call on the host connection as well, and it's going to ensure it's reliable. And then it's going to start the game for everyone. Right, let's test this out. So host game, join game, start. You see that right. The game has started for both, even though the player has done nothing. The client has done nothing, but the server is able to control the player instance remotely by using this RPC. Right. So this ensures that you can do something synchronized, right, on everything, on every connection. Right. Very useful RPC. Okay, maybe now the question you're asking is, although you have synchronized the starting of the game data inside the game is still not synchronized, right? So this thing requires some more work, and we're going to cover this in the next tutorial, the next workshop, right? It's a bit too much to cover for this. Right, so this is the RPC for starting game. We're done. Okay, we have done this one also. Let's see what's left. Okay, so the last thing we are gonna try out today is wait, no. Is how to update other players with your information, right? In the lobby, often it's a very often use case that you want to gather all player information. You want to send your name to other players. Maybe you want to add a profile icon, right? You want everyone to synchronize all the player information. And we can achieve this with RPC. Okay, so let's just have this function called update player info. And we're gonna make it RPC, right? RPC. Okay, let's make it any peer because you want every member to be able to call this update player info on every instance, and it should update its own information as well with its own information, right? So let's do call local. And when this happens, what we should do is to add the information of the player to this player dictionary that I have defined above, right? Okay, maybe we should have ID and name as arguments here. And let's just do players square bracket ID equals this dictionary of ID being the ID and the name being the name. All right. So this is the RPC. And where should we call this RPC? Right. When should we call this RPC? Let's listen to your opinion. Where in the code do you think that we can call this RPC to update everyone with my information? Is it somewhere with the connection signal? Any ideas? on pair connected. Okay, that's a good guess. Let's try it. Right. So this pair connected signal is being called when you detect another pair has joined, right? This one has an ID of the ID of the pair, but it doesn't have the name, right? Actually, the main target we're getting at is to save the name instead of the ID, right? So this shouldn't come from this peer connected signal. It should come from somewhere that we have access to the name. Right? Who have access to a player's name before connection or at the time of the connection? Is it other players or the player is player himself or herself? The player himself, right? So we should call this at the connected to server function. When you connect to the server, right, you have the information about your name in this name input. And you can call this RPC to update everyone with your name, right? Let's do this at the connected to server signal. Let's do update player info, right? The ID can be multiplayer dot get unique ID. And then the name, let's just get the name of this name input. Name input dot, it should be text. Right. Remember this is just calling the function, but not the RPC. You should do dot RPC. Yeah, with the same thing in the bracket. All right. We should have this display names timer working now. It should log the name of every player that has been saved in the player dictionary. Okay, let's try. Join game. Let's wait for 5 seconds, I believe. Okay, something is not working. Let's see why. It's one being enabled. Oh, I never auto start this one. Maybe that's why. Let me try again. Ah, but the information is not being updated for some reason. Let's see why. Yeah, let me refer. It's been quite long since I prepared this. Uh, right. Update player info. Maybe it's because it's not reliable. I think the only difference I had with my code is reliable. Yeah, let's just try. Oh, okay. Oh, I think it's because I never put the name, is it? A, B, C, E, F. I'm stupid. Am I? Okay, I'm stupid. Okay. Okay. But there's an issue here that the ABC player, the host, has not been printed in this. It's because the connected to server is not called for the host itself, right? Let's fix this. Okay, so long story short, there's no issue with the code. It's just that I forgot to input the name, right? So the code is correct, right? So update player info should be called when you host as well, right? So for the host, the only place that you can do is in the host game button pressed. So let's do update player info with ID. You can just put one because we know that the ID of the host is one, and then name similarly being the name input dot text, right? And notice that we don't have to call the RPC here. We don't have to dot RPC here, right? Because there's no need to do RPC at the time that the game is just being created by the host, right? So by doing this, we're not using the RPC. We are just calling the function on the host itself, right? It's just a plain function itself to update its own to update its own dictionary, player dictionary, right? But that left us with another issue is when other players join the game, right? This is not being updated. The host information is not being passed to them as well, right? So other than this, we also need to update player info when others join us, right? When we see someone join us, we should also update them with our info, right? That's the missing piece of the puzzle. So, so where should we do that? Okay, so actually you are right at the first time, right? We also need the function under peer connected, right? When you see a peer being connected to your room, any other peer should send their own information to that one. Okay, so on this peer connected, let's also do update player info. And this time we only need to inform that one particular peer. So we can do RPC ID, right? RPC underscore ID. And the first argument you pass to this RPC ID is the ID of the peer you want to call this function on, right? So just the ID of the peer that has just connected, right? ID. And then the following arguments, just by the order of the argument you want to put in the original function, which is your own ID, multiplayer dot get unique ID, and your name. So in the name input dot text. Okay, this should fix the game. Let's see. Host game, join game. Oh, I forgot to put the name again. Let's do host for the host. And okay, let's just see the host has been updated for the host itself, right? And player join game. Okay, you can see that both of the logging is correct, right? So for the host, you see host and player, well, and the same for player, right? But here's an issue, right? When you close the player, right? It's not being updated yet, even though the player has left the room, right? It's still host and player. So we can also easily fix this by just another signal, right? You also have a signal when you detect other peers have just left the room. Then you just erase that player's information from your record, right? So for this one, it's simpler if we have the ID. The ID is gonna help We can just remove the ID entry, the entry identified by this ID, right? So on the peer disconnected, right, we have this players dot erase, right, the ID entry from your player's information. All right, let's try. So host will host the game, and the player is gonna join the game. Right, host player, player host. Now let's make the player quit the game. And let's see. Right, now we only have the host. Right. So this lobby has been in sync now. Okay. Right, let's see whether there's something left for us to do today. Oh, there's one more thing, one more edge case that we should handle is when the host quits, right? Host hosts a game and the player joins. Let's just see what's the current behavior when we close the host, right? So server is disconnected. Please join another room. And now it's still printing this player because your current player information is still inside, and we have done nothing to enable this text, right? Maybe just for completeness, let's complete this. So when the server has disconnected, let's do players. Let's reset the players to be the empty dictionary, right? And then for all the properties, the disabled properties I've set here, when you join a game, let's just reverse all of them. Okay, so when the server disconnected, let's do I copied from the on join game button pressed. So let's just reverse them. So let's enable the editable property of name input, enable the host game, and enable the join game. Equals false, equals false. Okay, so this should complete the lobby, I hope. Let's see. Okay, let's disconnect the server. Right now, you can change your name again, right? And you can see that there's no player being recorded in this instance. Then I can host the game and start the game as usual. All right, I think that's it for today's content. Any questions? Right, let's see if I have more slides. Right, okay, that's a basic connection logic for multiplayer. Right, now you have all the skills you need to synchronize before the game starts through this peer connection, signals, and RPC calls. And next week, actually it's gonna be 11 and 12, right? Since there was no session last week. Next week, we're gonna look into the synchronization feature of a multiplayer. So instead of just synchronizing in the lobby, we want all the game data to be synchronized after the game starts. That means when one player kills an enemy, right, or damages an enemy, this damage or this dying of the enemy will be reflected in the other player's screen as well. And that's what makes the game truly multiplayer. Okay, so hope to see more of you next week. And thank you for coming to, or thank you for watching this week's tutorial. Right, see you next week. Bye-bye.